In this discussion, we'll take a look at sensation and perception. Basically, what sensation and perception is, what is the difference between them, and the many types of ways that we sense and perceive. So importantly, just keep in mind that we are constantly in our environments, constantly surrounded by sensations. Now, the thing is we're not able to process all of that information at all times. There's just too much visual, auditory, touch, temperature, that kinds of things. We're constantly being presented with that, environmentally speaking, but we're only able to actually perceive a percentage of that, usually based upon what we are doing at the time or what we are concerned with at the time. So just kind of keep that in mind. Okay, so what are sensation and perception? What are the differences between them? Often students are a little surprised that there is a difference between these two. They think they're one and the same. They think, well, if I sense that, therefore it is. But actually, this involves a process where one comes before the other in the process. So let's take a look at sensation. So sensation, that's basically when we detect basic sensory experience and environmental stimuli. So basically that means, all the things that I referred to a little bit earlier, visual, auditory, touch, that kinds of things. So when our sensory receptors in our body actually sense those, that information is then sent along certain pathways into our brain in order to process that. And so that system of processing is known as perception. So basically in perception, individuals are integrating, organizing, and interpreting sensations in meaningful ways. So take, for instance, when one touches a hot surface, one will actually feel that, sense it, to be a little more direct, and then it's actually sent up into our brain, and our brain actually processes, integrates it, organizes it, and then we say to ourselves, ouch, that is hot. So that becomes meaningful to us. So this chart right here, or this visual diagram right here, that actually just explains, the basic steps of sensation and perception, how that occurs. So you can see, starting at the left here, this individual is smelling a flower. So this actually receptor cells in our sense organs, let's just say our sensory organs, that help us to sense smell. So basically what is happening is that is step one, and then the coded neural signals are sent along in this direction up into the brain, and then the brain actually processes that, which is called perception. And then that became the neural signals, or the information that this individual actually received, was able to put it all together and say, oh, it smells like a lily. So that became, it's actually making meaning of the incoming sensory information. So a few things to keep in mind. These are a few terms right here that you should be aware of. And for one thing, sensory information is actually at first it's basically it goes through our what we call sensory receptors. So it's a sense organ that responds to a form of sensory stimulation. So all that means is when one touches something, it's actually the sensory receptors in your fingers or your toes, whichever you're feeling with, or somewhere in the body. And so it's the receptors that are receiving that sensory information. Now the thing is with constant dealing with that sensory information on a repeated basis, eventually it's possible that one will be a little less sensitive to that stimulus, will adapt to it. So take, for instance, when one walks into a room and one, at first, maybe, there's some loud music playing or something. And at first, you may say to yourself, wow, that music is a little loud, but if you stay around long enough, eventually you might adapt to that level of volume in the music. And so that is what is called sensory adaptation. Okay, now keep in mind here, you remember the steps involved between sensation and reception. Remember there's the sensory type of organs, actually receive the incoming information, and then it is sent along pathways to the brain, which actually starts to organize it, make sense of it. And so basically, that process right there, being sent along into the brain and being processed through the brain and the spinal cord, that is actually called transduction. Okay. So we're going to take a look a little bit about different types of sensation. And first of all, we're going to talk about vision, how we see, what we see, that kind of thing. So one thing that's important to keep in mind is we humans, we actually perceive and sense a certain amount of light that along what's called an electromagnetic spectrum. Okay, and we're only able to perceive a small bit of what actually exists on the spectrum. So we can actually perceive as humans and actually sense this small bit right here that's highlighted right here. And so these are, according to the actual wavelengths right here, those wavelengths actually result in sensation and perception of different colors. So this shows you right here. Please, you do not have to memorize this as far as, the wavelengths, in nanometers, that kinds of thing. But just show you that the human eye is only capable of sensing and perceiving, transducing and sensing, a small portion of the electromagnetic spectrum. So this is what happens right here. So the eyes actually will perceive the incoming information. And what is interesting is, take for instance, I'm just looking at this eye right here on the right hand side of our screen. The information comes in and then it is transferred along into what's called the optic nerve. And then right here at the optic chiasm, right here, it actually switches sides. So the right eye the information is sent to the left side, to the left hemisphere of the brain. So you can see right here it actually crosses over, and then it is sent right here into, remember, the occipital lobe. You should recognize that term, through our neuroscience studies that we did in earlier chapter. But right here, the information is sent into the optic lobe on the opposite hemisphere. Okay, so just kind of knowing that and moving forward with that foundational knowledge, let's take a look at how we actually see. So we're, an important part of that discussion is being aware of the various parts of the eye. And so basically we have what's called the cornea. That's the clear membrane, right, that covers the front of the eye. That is the outermost membrane that's covering the front of the eye. Now we have what's called the pupil and the iris. So you remember the colored part of the eye, that's called the iris. Okay, so when one says, I have blue eyes, one is actually referring to their iris, the color of their iris. And then right in the center of the eye is usually a hole that actually expands and contracts, kind of like the lens on a camera. And that is actually called the pupil. And the reason why that expands and contracts, kind of like a camera lens, is because that's actually basically controlling the amount of light entering the eye. Okay? All right. And so now we're going to move forward and discuss the lens. And so that's actually right behind the pupil, and that focuses the image onto the retina part of the eye. Now I will show you a diagram of that, so all this, you can actually see what this looks like. So here's the diagram. Here's what it looks like. So on the outer front membrane right here, remember this is the cornea right here. And then we have the iris and the pupil right here. And then we have the lens. Remember that actually, and that sends actually the image all the way to the back here to the retina. So the retina is along back here, okay? And then once that image is actually projected onto the retina, then it is sent along the optic nerve right here, which will eventually meet the optic chiasm, which will send that to the opposing hemisphere of the brain. Now, keep in mind, at the back of, the eye there, there's some types of structures here called rods and cones. So definitely cones are actually what responsible for our perception of color. Okay, color vision. And those cones are what are active during daylight, or when there's basically a lot of light available to the eye. So it's the cones that do that. On the other hand, we have what's called rods. Now rods, those are what are responsible for night vision. And basically, I put a note in here that they take, roughly 30 minutes to adapt to lowest light levels. So that should sound familiar to you, because take, for instance, you might be in an environment with a lot of light, and then you will move to a different room or go outside or something where it's dark, and you'll notice that it takes a while to adjust to that, where you can see in the dark. Well, that right there is the rods slowly adapting. And remember the rods and cones, those are kind of along the back part of the eye. And that is called, remember that's called the retina. So remember that is the membrane that's at the membrane that's at the back of the eye. And that is where the rods and the cones are actually located. Okay? And so right here, mainly just to kind of keep in mind that in the rods and cones, when they are processing, levels of light and darkness and things like that, that is where chemical reactions occur that send the neural signals, along the optic nerve and then eventually into the optic chiasm, which eventually, goes into the back of the brain. Remember the occipital lobe. So here's actually a very close-up view of the rods and cones. This is what they actually look like in the retina. Now, this is just for just kind of like a FYI kind of fact here, but we do have where basically we have a blind spot in our vision where we're not able to actually sense a certain amount of incoming visual information, and they call that the blind spot. But what is important to know is the actual brain actually fills in that blind spot with patterns that make sense for that environment. And definitely also movement of the eye that actually also helps fill in the blind spot. So it's a combination of the eye moving fairly, let's just say fairly rapidly for our causes right here and for our discussion. And then the brain fills in the rest so where it makes sense to us. So our environment doesn't seem disjointed and there's holes in our perception. Okay, taking this discussion just a little bit further, we will talk about how do we perceive color. So you remember, color is actually processed through, information that helps us to perceive color is processed in the cones part that are located in the retina. So that's what allows us to see the different colors. Well, there are basically a few terms here that I'd like for you to be aware of. So the term hue means basically the I will say this in very simple terms, that's how we, referring to color. So when we look at this right here, if you can see where my cursor is right now, this color on top here in this diagram, this, we tend to say that is red. Well, we're actually referring to what's called the hue. Okay? Now, saturation, that refers to basically the intensity of the hue. So it can be, if it's light red or very deep red, we're actually referring to what's called saturation. And brightness, that just refers to the level of light that actually enters our eyes. And I don't think I need to take that any further. I think that's simple enough. So we have what's called the trichromatic theory. So basically all that means is I'm going to move backward here. So we can basically see that we have a red, blue, and green colors right here. And those actually can combine those three colors in order to create all the rest of the colors that are right here in the middle. So I'm going to go back here again, and that's, three different colors, hence the term trichromatic. So chromatic just means color, basically. So three color theory. So that refers to the mixing of those three colors that can actually create the other colors that we perceive. Okay, moving forward. We also have what's called the opponent process theory. So basically, that just says that we're able to perceive color because of opposing pairs of color receptors. So you remember, there's basically three systems that are called red, green, blue, yellow, and black and white. It's those three systems right there that actually enable us to, when we perceive that, like say the red-green hues, these other systems are temporarily turned off or inhibited. And so that's called the opponent process theory. And so let's just leave it at that for now, and we will take that a little further as we go. Okay, so we're going to shift gears here a little bit. We're going to talk about hearing. So what do we hear? So basically, we hear sound. And sound is nothing more than actual vibrations in the air or in the environment that reach our ears. And there are different types of vibrations. They can be really fast. They can be very slow. They can actually have different, the actual waves in the air, the vibration that causes the wavelengths to reach our ear. So those can actually influence basically how loud or how quiet a sound is. So there are three terms I'd like for you to be aware of, okay? And so they are this. So amplitude, you can see right here on the far right, amplitude is just another way of saying the amount of volume. So the higher the amplitude, the louder a sound is. And remember, amplitude, because the arrows are going straight up and down, that refers to the actual height of the waves, the wavelengths. Okay, but we also have what's called frequency right here. And you can see frequency means how frequently each wave appears. So all that means is due to frequency, we actually perceive how high-pitched or low-pitched a sound is. Okay, so when we hear the difference between, take for instance, the sound of a train going by, or the sound of a violin playing very high notes, the reason why we're able to actually discern the difference between those and say, oh, that violin has a much higher pitched sound, that's because the frequency of the wavelength created by the violin is actually increased, whereas the sound of a train might, be, the actual sound of the train, train on the tracks might be a lower frequency, and so it sounds a little bit lower pitched. Okay, hope that makes sense to you. So there are a few terms right here. I highly recommend you definitely pause the video and become familiar with these terms. And so you remember loudness, that means the amplitude of a sound wave. Okay. Okay, so remember loudness basically refers to amplitude, which loudness, basically the unit of measurement when we're measuring loudness, we use the term decibel. Okay. Now remember, frequency, that just refers to the number of sound waves per second that actually result in our perception of what we call pitch. So pitch basically refers to the highness or lowness of a sound. So when we know the difference, when we're able to hear the sound of a flute compared to the sound of a tuba, that's because we're actually perceiving the pitch difference between those two instruments. Now here's a word right here finally that most people are not aware of unless they are, serious musicians or something. And this word right here is pronounced timbre. It's not timber, it's timbre. And that is basically just refers to the quality of a sound. So you remember I said, when one perceives the difference between the sound of a flute and the sound of a tuba, you're actually referring to the timbre of each one, the distinctive quality of each instrument. And that's what actually enables us to discern the difference between various sounds that we hear in our environment. Okay, so how do we hear? So basically this diagram just says a few different things. So the outer ear right here, that actually collects the sound waves, okay? And then the middle ear right here, right in the middle of the ear, that actually amplifies the sound, makes it a little louder for us to hear. And so there are 3 small bones in the middle ear, and they are called the hammer, the anvil, and the stirrup. And all those work together to amplify the sound that's coming into our ear. Now finally, the inner ear, that's where the sound is actually transduced, remember that term from earlier, into the neural impulses that go to our brain and actually help us to eventually, remember, result in perception, making sense of what's coming in. So in the inner ear, there are a few different structures here that I'd like to just make you aware of. The first one is called cochlea, right here. That's the fluid-filled inner ear structure, and that contains what's called the basilar membrane and the hair cells. Okay, so what are those? Well, the basilar membrane right here, and that contains that actually, remember, that's the fluid-filled kind of surface, structure. And that actually contains the hair cells. Now, what are the hair cells? Well, those are actually sensory receptors for the sound. And so they get brittle and damaged as you age, and especially by loud noises. So take, for instance, when one experiences some hearing loss, because of loud environments, either with work or loud concerts, or something to that effect, that is actually damage to the hair cells that results in that hearing loss. Now keep in mind here, you remember I said, we're able to say, oh, that's a very high pitched sound compared to a lower pitched sound. Well, remember we're talking about frequency of the sound waves that are reaching the ear. And that's why frequency we're going to refer to what's called frequency theory. And this is interesting because remember the basilar membrane part of the ear, that actually vibrates at the same frequency of the sound waves. So that's what actually helps us to kind of perceive certain pitches of sound, basically. Then we have what's called place theory. And basically, that just means that different frequencies that enter the ear cause different rates of vibration at different places in the basilar membrane. And you notice, like I said, different places. That's why they call that place theory. Okay. So place theory is basically what helps us to hear high-pitched sounds. You know, like the sound of a flute or nails on a chalkboard or something like that. You know, so keep that in mind, please. So frequency theory, that's for lower pitched sounds, and place theory is for higher pitched sounds. All right, so we're going to shift gears here and move on to other types of sensation that we're able to experience. So we have a couple different type of chemical senses, okay? Right here. Let me back up just a little bit, though, before I say chemical senses. So there are basically a couple different kinds of senses, and we have what's called chemical senses and bodily senses, or body senses, okay? So moving forward now, we will talk about chemical senses first. We have two terms right here. We have olfaction, which refers to our sense of smell, and then we have gustation, that refers to our sense of taste. Okay, that's all you have to know for so far. Now we have what's the bodily senses, or the body senses. We have things like touch, temperature, pain, kinesthetic. That means location of the body. All right, and then we have what's called vestibular, and that refers to basically our sensation of balance. So one can see that definitely all of those are important, and we're constantly using those every minute of our lives, basically. So take a look here at the olfactory system. Remember, olfactory refers to our sense of smell. Okay. And we already kind of looked at this a little bit earlier with a diagram of the person just smelling a flower. And so you remember, this person might be smelling some fruit, a strawberry in this regard. And actually what's happening is the strawberry is emitting what's called airborne odor molecules. And those actually go up, right up here, through the nose. And then those actually enter what's called the olfactory bulb, or olfactory right up in here. That's the part of the brain that actually is able to send that information into parts of the brain for processing. And here's just a quick, right here, an actual enlarged image right here of what's called the olfactory nerve. And that is what it looks like. So right here in the sinuses, here are the receptor cells right in here in the sinus membranes, but those go directly up through parts of the skull into the brain. And remember that part of the brain that it's called the olfactory bulb right here. So that goes directly to the brain. Okay, so for our sense of taste, remember that's called gustation. And we actually, our sensory receptors for the sense of taste are our taste buds. Okay, and so basically, the taste buds, they tell us a lot of things, like basically aroma, temperature, texture, appearance, all that kind of stuff. So right here is an enlarged image of a singular taste bud. This is actually what they look like right here up close. Okay, so moving ahead, we're going to talk about skin and body senses or sensation. So a couple things, just keep in mind the skin, is the largest and heaviest sense organ in our entire body. And, as this says, contains many types of sensory receptors. Okay, so as I said, the skin contains many types of sensory receptors. So some specialized receptors, they may only respond to one type of stimulus, whereas other receptors can respond to multiple types of sensation or stimulus. Okay, so just kind of keep that in mind. Okay, so looking forward here, just want to talk about this term right here that's called the Pacinian corpuscle. That's located right beneath our skin, okay, and that's what sends the coded neural message to the brain when it's stimulated. And then eventually adaptation, occurs when the pressure is constant. So take, for instance, when one is maybe experiencing, like a certain sensation, like coldness, like if you put a cold pack against your skin, at first it's very stimulating and it's very cold, but eventually you'll notice that basically the skin becomes, we tend to say numb. We've adapted to that. That's what that numbness is. It's adaptation. Well, that's actually the Pacinian corpuscle that sensory adaptation occurs, okay, when that stimulus is constant. Okay, now the thing is we have in our systems right here, our sensory systems, basically, we have different types of fibers that actually go, send information to our brains. Okay, so we have what's called A delta fibers. Okay, and that's actually basically A delta is our fast pain system. So when we feel something immediately, like when we touch something that is hot, and we pull our fingers away, our hand away very quickly or something, that's actually our A delta fibers that sent that sensation up to our brain very quickly and allowed us to act. On the other hand, we have what's called C fibers. Okay, and C fibers is our slow pain system. And so basically, that is the longer lasting throbbing, type of pain that might result from injury or something. So take, for instance, one might stub one's toe or something on something, or something to that effect, and might feel the pain immediately through the A delta fibers. But then, say the toe is bruised and a little sore for a couple days, and it's a little bit throbbing. Well, that right there is the C fibers in the pain systems that are actually sending that signal up to the brain. Okay, let's move forward. Now this right here is a term called gate control theory of pain. And basically all that talks about is it proposes that basically pain signals are sent along the spinal cord. Okay, so right here, pain experience is interpreted by the brain, and then the brain sends that signal down the spinal cord. Now, depending on whether one feels that pain in certain parts of the body, might depend on what's called the gate control theory. So all that refers to is along the spinal cord, there are certain gateways. And if the gateways are open, then pain is experienced or intensified. But if the gateways are closed along the spinal cord, then the pain can be reduced or nullified. So just kind of keep that in mind, please. All right. So we're going to talk a little bit about, movement, position, balance. And so basically that refers to our kinesthetic sense. That's what this is right here, kinesthetic sense. And that is the sense of location and position of our body parts in relation to one another. So definitely, very simply, it's just everything we do with our bodies throughout the day depends upon our kinesthetic sense. Like take, for instance, if we want to wave hello at somebody across the room, it's our kinesthetic sense that allows us to point basically our waving hand in the direction and of the person that's receiving the hello wave. And as a reminder, just want to also talk about this term here, vestibular sense. So that refers to our sense of balance, okay? And that's, I don't think I need to elaborate upon that too much, but our sense of balance, how we feel balanced, is our vestibular sense. And last but not least here, in this part, we're going to talk about proprioceptors. And those proprioceptors just refer to our sensory receptors that are in our muscles and joints that actually help, send information to our brains about our body position and how our bodies are moving. So take, for instance, for those involved in an athletic endeavor, no matter what it is, but it's the actual proprioceptors that are sending information up to our brain constantly in order to help us to know the position of our bodies and how it's moving, okay? Okay, let's move forward here. So there are two different types of processing that can occur here in perception. We have what's called bottom-up processing. And bottom-up basically just refers to we can visualize this very simply. Remember, we have sensory receptors throughout our body. And the body is lower, usually, at a lower level than the brain. Hence the term bottom-up. So actually the processing that occurs in the sensory receptors and moves from the body up to the brain. Okay, and the brain is, remember, receiving information from the body, and so that can also be called data or data-driven processing. Okay, so the body sends data up to the brain, and the brain processes it. Now, on the other hand, if the type of processing actually originates within the brain and works its way down to the body, so that is actually called top-down processing. Okay, so remember that originates in the brain, and that's why they called, cognitive processes. How the brain functions, how the brain is actually functioning. Okay, let's move forward here. Okay, so now we're just going to take a look at a couple other types of perception, basically. And so here's the thing, we're going to take a brief look at this, what's known as ESP, or extrasensory perception. So think about the meaning of that word a little more in depth. Extrasensory. That means perceiving without sensing. Okay? Minus the actual phase of sensing. So ESP, that means detection of information through a different means other than normal processes of sensation. Okay? So I'm not going to choose a side or anything. I just want to make you aware that ESP basically implies extrasensory, meaning perception without sensory processes. Now we'll also briefly talk about parapsychology. And so basically that just means scientific investigation of claims of various paranormal phenomena. Okay, so remember that, when scientists are trying to actually see if claims of paranormal phenomena are basically can be proven. So that field right there is known as parapsychology. So keep in mind, there's always a controversy about these right here. And just another thing too, scientists, are generally pretty skeptical of ESP, and parapsychology and stuff like that. So, because remember, scientists employ the scientific method, and it has to be observable data that can be usually generally measured or reported. And so quite often, things like imagination, or feelings or something like that, or, really are not observable data that can actually be reported scientifically. So that's why they say that there is a controversy there about things like ESP or parapsychology in general. Okay, so let's move forward here. Okay, let's just briefly talk about, well, how do we perceive shape? So when we are actually, in our environments, when we're looking at everything, we are seeing basically a specific shape to everything. So, if you just take a brief second and look around you, you are perceiving shapes in everything you actually sense and perceive. Well, that process right there, psychologists actually basically gave that a name, and they called that Gestalt psychology. Okay, and so basically Gestalt psychology basically just proposes, that humans, we perceive objects or figures as a whole rather than isolated bits and pieces of sensory information. So when we look at like take for instance an apple, we're actually perceiving that apple as a whole unit, a whole unified unit. We're not looking at it and saying, oh, that is something that looks like a piece of fruit that is semi-circular in shape. It has a certain texture and things like that. We actually just perceive it all at once as a whole unified type of object. Hence the term Gestalt psychology. So, take for instance, we look at things and we perceive them a little differently, so when we perceive something as a whole, we can actually perceive it a little bit differently at times depending on how we look at that. And that depends upon what's called the figure-ground relationship. So basically, figure-ground relationship means how we actually sense and perceive an object in relation to what its background to its background. So I did put this image here. This is something that we're all familiar with. And when we look at this image right here, do we perceive this as two faces that are looking at each other, two humans that facing each other? Or do we look at this center right here and say, oh, that's a type of, I don't know what you call that, basically maybe a vase or, something like that. So it all depends upon the actual figure in relationship to its background. So when we look at this, the two faces right here, the right and the left, the blue, we're actually looking at those, as the basic figure, and then we are looking at this white section as a background. Okay, so that's why they call that the figure-ground relationship, how we actually perceive that. So a couple things, the Gestalt psychologists, we actually have determined, Gestalt psychologists have determined that, we actually perceive, different elements, like things like patterns, shapes, forms, and we do that in a few different ways, okay? And we actually perceive our environment through different laws. So we have what's called the law of similarity, the law of closure, law of good continuation, and the law of proximity. So we're going to take a look at those, some examples, okay? So right here, this is the law of proximity. So on the left, we look at all of these black dots or blue dots, whatever they are, and we look at those as one unified whole. We just look at that as a group of dots. But then on the right-hand side of this, all of a sudden we see groups of dots right here. 3 groups of dots, right? Okay, so the reason why we do that is because we're, those right here, these little groups of two groups of dots right here, and then there's a space right here, and then there's another set of two sets of dots or a group of dots, and then so anyway, that right there, because these are in proximity, these are close to each other, our brains actually tend to perceive that as being together. They are in close proximity. Okay, so this refers to the law of similarity. So our brains, in the process, in the process of processing this incoming information, as we look at this diagram, we start looking at what's similar and what's different. So when we look at these rows right here, we see, basically a light colored set of rows. And then the second row right down here, we start seeing that as a dark colored set of rows. And then they alternate. We start saying, oh, those alternate. Well, we're actually able to perceive that. Remember, perceiving means organizing and actually putting these into categories. But we're saying, okay, well, all these light colored on this row right here, those are similar. Hence the term law or principle of similarity. Okay, now as we're looking at this right here, this is the law of good continuation. All right. And so as we're looking at this, we see basically these two lines, I guess we could say. One going this way and one going this way. Okay, so basically we tend to perceive this as basically 2 overlapping lines. One going this way, one going this way. Instead of 4 different, say right here, instead of seeing this as 1 line, 2 line, and then from the bottom up, 3 lines, 4 lines, we actually just perceive this as a set of 2 lines that are moving in a continuous type direction. Hence the term good continuation. So our brain actually just puts together this information and makes a judgment call, basically, that these are, 2 overlapping lines, generally speaking. Now we'll also briefly discuss the law of closure. So closure right here, even though, like, take for instance, we look at this right here on the left and we say, oh, that's basically a circle. And this is a rectangle on the right. Well, instead of perceiving this right here as a whole bunch of segments that are just random, we actually look at this as a, we actually close up the missing parts and we say, oh, that is a circle. That's a spherical type shape. Okay? So that's called the law of closure. Now finally here, we're going to just talk about some illusions too, and how we actually perceive, how our brain actually processes information coming into it, maybe not so accurately. Like take for instance, this is what's called the molar-liar illusion. And that just refers to when we look at this, like right under here under letter A, we look at these two figures right here and we say, okay, well, look, definitely we can assume that the middle black line on the right here, that is much longer than the middle black line here. But actually, they are identically the same in length. Okay. So definitely our sense of perception isn't 100% accurate all the time with what we're sensing. Okay, so just keep that in mind. We actually experience illusions in our environment. Now, we need to speak a little bit about, since we are talking about perception and everything, but keep in mind that we sense depth. So definitely when we're looking ahead and we say, okay, well, the computer is roughly 1 foot or 2 feet away from my eyes, we're talking about depth perception. Okay, so what's important to know is depth perception is the result of our two eyes basically working together to send information to the brain to be processed. And so because it's two eyes, remember eyes, we can also use the term ocular, and hence the term binocular type vision. Okay, so it's the two eyes working together. And so right here, just moving forward, we're here. So binocular, I've already explained, that means basically, that's how we experience both eyes working together by comparing their information that they're taking in. And then we have monocular, which basically just means one eye working at a time. And that concludes our discussion of this. I realize there's a lot of scientific information in this. But hopefully this will give you further insight into the processes and the differences in sensation and perception that occur and how they all work together throughout our daily lives.